Hello.
Hi,
Hi. How are you?
I'm good. How about you?
Not too bad. Not too bad at all. What you got going on the rest of the day?
I'm like at work right now. So I'm like on break and then I go back to work at like 2:50.
Okay.
So that's pretty much it right now.
Gotcha. Don't want me asking what kind of work you do.
I work at a daycare.
Ooh.
It's my like she has like an in-home daycare thing.
Oh, very, very cool.
Yeah, so I've been doing like online and then I work the rest of the day. And I've been doing pretty good with the online, but like the algebra, the math is so hard to teach yourself. Like I
Yeah.
can't.
Yeah. Yeah, that's very cool. So, I do a lot of you know, tutoring, obviously.
Yeah.
That's about half of what I do. The other quarter, I'm a soccer coach.
Oh, that's cool.
Yeah, the other quarter is I do some data collection for a after school program. So
Oh,
I
okay.
know all about working with the little ones.
Yeah.
Bunch of crazies they are.
Well, I'm with like infants to like 5 years old, and it's
Oh, okay. So even
insane.
younger. Okay. Yeah, I'm more in
Yeah.
the elementary to middle school range.
Yeah, they're better
Yeah.
probably than 2-year-olds.
Yeah, yeah. Um yeah. Yeah, we got a couple younger ones. Probably have like 8 or so like K through 2, but most of our kids are from like 3rd grade to 7th grade.
Yeah.
Yeah. Very cool. Okay. Let's see. Well, so I don't really know you yet as like a math student. So,
Yeah.
um, shoot. My headphones are on low battery. I really hope they don't run out. uh, no, just a second. Why don't you, while I'm getting this set up, why don't you tell me a little bit about kind of what you've been working on, what's been kind of hard, that kind of thing?
So like when I was in-person school, I was much better at math. Like I feel like it's much easier like to learn cuz last year I was in geometry and I was
Mm-hmm.
so bad at that. I had to do tutoring again. And I can get a lot of it, but it's also like I don't know, it's hard because they don't have like Zoom calls and like stuff like that on mine. It's like literally you get a slideshow, you read it, and then you do it. So it's not really like getting the chance to really learn it, especially because I am a teenager. So it's like I don't really want to learn it half the time.
Yep.
So
Very true. Very true.
I'm like,
Okay.
I definitely got Algebra 1, but Algebra
Okay.
2, it's like, I don't even know. It's
Okay.
crazy
So you are
for
in
me.
algebra 2.
Yeah.
Okay. So algebra 1 was good. Geometry was hard. This sounds like
Yeah.
it's been hard. Okay. So what I like to do is if you have any topics that you want to start on, uh, we can start there. Then as we talk,
Okay.
I'll kind of um, I'll kind of see some other stuff that we should work on.
Yeah.
So is there like a current topic that you're working on, either like right now?
So, like, I do, I've been doing like, that's the one, this is the class I'm the most behind in, just because a lot of the times, I know this is bad, but I do use Chat GPT and stuff. So I kind of wanted to just, I don't know, not really start from the beginning, but just like I need to learn like the basics from someone who knows how to do it,
Yeah.
like not teaching myself.
Okay. So
Like
what I'll say
we
to
do,
that is the basics are different for different people. So
okay,
I've like in like calculus 1 or in pre-calc, I've had to um, like we'll be doing problems, and I realize, okay, they're like pre-algebra, algebra 1 skills are really bad. We need to go back and
Yeah.
do those. So,
Okay.
but for other people, it's like, oh, they just don't understand this particular topic. We'll dive into that. So, I don't know what your baseline is yet.
I can like do you want me to like show you or do you want me to say like some of the topics they start us with maybe?
Yeah, that would be good,
Like
so
cuz
I can
we
know
it kind of
what your school's doing.
I got like the beginning. Like it was like linear equation, graphs, functions, domain.
Okay.
The main thing actually I don't understand the polynomials
Mm-hmm.
I don't get, and then like the factor, like the
Factoring.
function, like the f of x thing.
Uh-huh.
Like I did that in algebra 1, but it was like much easier than like these long equations I don't understand.
Okay.
Um
All right. Let's talk about functions then.
okay.
That's a good baseline. So, do you know what a function is? If you could define it for me.
Um Not really. Like I can't really define it.
Yeah.
I'm sorry. I'm not going to be too good at this.
No. I'm like this is what I do. So don't ever like feel bad for not knowing stuff. Um, let's see. So I want you to think of a function as a machine. Uh, you may have heard examples like this. You got a box, and the function, we'll just call it f of x. This is usually how we write function.
Yeah.
Um, a function is a very special tool that turns one number going into it, usually called the input, that's our x, into a different number called our y. And um, the function, the machine, will change the number in the same way for each other number. So, for example, if our function is x plus 2, what this function is doing is it's saying um, whatever number we get in, we will add 2 to, and then that will be our output. So, if we get 5, we add, so our input is 5, so that goes into the x spot, and that goes into
Okay.
the x spot, and then we get out um, the number 7.
Okay, that actually makes sense.
Yeah, so all functions are is a function will turn a number into another number following a specific set of rules, and these rules is math. So addition, subtraction, multiplication, division, exponents, logs, all this stuff. All these like presets of like the machine that we use will allow us to change numbers in specific ways. So this is what a function is. So
Okay.
when we're talking about like polynomials, um, a polynomial is something like this. So do you know what polynomial stands for?
No.
Me neither. Let me see.
Yeah, I was like, I really don't know anything right now.
Polynomial definition. So there's kind of two parts. There's poly and nomial. So nomial has to do with like name,
Okay.
and poly means multiple. So the kind of key idea here is that there are multiple terms that we can't
Okay.
combine. So, for example, we can't add x squared to x, and we can't add x to 1. Do you know why?
Okay. Yeah, because they're not like terms. Like
Yep.
You can't add like term. Okay, yeah.
Yep, very good. But if we had plus 2, we can add these together. So it's like
Yeah.
it's just like we add it as much as we can, and then this is what we end up with. So
Oh, and that's the polynomial?
yeah, so this
Oh, okay.
is a polynomial. Um,
Okay.
and really, so really it's a trinomial because there are 3 terms.
Okay.
Polynomial is just any amount of terms. So if we had x squared plus 1, this is a binomial because
Okay.
bi is 2. And if it was just one term, it would be a monomial because mono is 1.
Okay.
So that's the kind of naming system. And, and so going off the naming system, so one part of the naming system is how many terms there are. And then the next part is the highest order. So this would be, I believe is how you would say it, a second order polynomial. Let me double check that. Yep. So this would be a second order trinomial, is how you
Okay.
would say it. So you first look at the highest exponent and then how many terms there are. But
Okay.
oftentimes we just call these polynomials. It's not super important how like what the power is or how many terms there are, unless you know we're doing something specific. So for factoring, we usually only want to factor trinomials of a second order.
Okay.
It becomes much harder to factor, like much harder to factor uh, things of third or higher power. So you know how there's a quadratic equation?
Yeah, I think so. I've heard of that.
Yeah, or a quadratic formula. So a quadratic is a type of polynomial. It's a very special type of polynomial. It's of the form ax squared plus bx plus c. So this function here is actually a quadratic. Do you know what I mean
Yeah,
by having a, b, and c here?
I think so.
What do they mean?
Okay, then I don't actually.
Okay. A, b, and c just represent numbers. So
Oh, okay,
these
yeah, I
aren't
think I did know that then.
okay. Yeah, it's just um we don't know what they are, but they're not variables like how x is.
Yeah.
So this is a quadratic, and um we actually have a very hard time solving for x. So like if we had x squared plus x plus 1 is equal to 5 or something, we actually have a very hard time trying to figure out what x is for this because we can't ever isolate x. Because, if we
Yeah.
try and pull out x, we'll get x plus 1 equals 5. We can't ever get x on its own, not without doing some special math. Um, but what the quadratic formula tells us is that x is equal to negative b plus or minus square root of b squared minus 4ac over 2a. So some guy derived this formula a long time ago, and we get the numbers from here. So
Okay.
if we don't have a number here, so like there's no number in front of x squared, we just say there's a 1.
Okay.
So for this particular quadratic, a would be 1, b would be 1, and c would be 1. We just plug those in and get our numbers.
Okay.
So that's how we find what x is for quadratics. But so this is called the quadratic equation. So this is kind of what I'm saying, where it's much harder to figure out things above this order. So this is the formula for quintic. So we have quadratic, quintic is the next one up.
Okay.
You don't have to know any of this. Um,
Okay. Okay.
the idea here is that um, quadratic is kind of like anything above quadratic is like really hard to do, and that's just kind of part of the math. Okay. Um, so back onto the idea of functions. The idea is very much the same. We take a number in, so I'll do 5 again. So our input is 5 as it goes here, and then we put 5 into the spot of the x's. And this is
Okay.
31, I believe. That's all really functions are. Does that make sense? Do you have any questions about like what functions are?
So like yeah, so they don't ever give you like ones like so it'll cuz a lot of mine they'll give you like something longer like 5 plus something or like in the function. Like they do something long like when you insert the 5 like it'll be something longer and those like are really confusing.
Okay, well, I'm not sure exactly what that means. Do you have like an example?
Yeah, let me see if I can find it. Oh, actually the like putting the functions on the graphs. I
Mm-hmm.
don't understand.
Okay, let's talk about that. So this is the idea with graphing stuff. So our graph is we plot our x values on this axis and our output, or f of x, sometimes called y, on this axis. So what this means is that each number that we put into the machine has a specific number that comes out of it. So what we already know is that um, if we put the number 5 into the x, we're going to get 31 as the output. So these will line up. So for purposes of graphing, um, we can do these for any number. So what we're going to end up finding is that we have like a bunch of, if we do this for every single point, we'll end up with um, something that kind of looks like a line, if that makes sense.
Yeah.
So that's the idea of graphing a function is we're really just um, we're doing that for every single number, and we're getting um, there's also there's 5, but there's also 5.1 and 5.00 or
Mhm.
5.01 and so on, and these will get slightly different outputs that are going to be like right next. We can do this for every single number. And oftentimes when we're like sketching a graph, we can't do every single number. That would,
Yeah.
take too long. So usually what we'll do is we'll grab a couple of points. So we usually grab 0 because it's easy, maybe 1, -1, and maybe 2 and 2. So we got like 5 points here. And
Okay.
what you end up doing is finding what the output for those numbers are, and it'll probably be something like uh, for quadratics, it's usually something like this. So this would be like x squared, for example. I didn't draw that very curve-like, but it's supposed to be a little bit curved.
Yeah.
So that's where it comes from. So anytime you're asked to sketch a curve, you're literally just grabbing a couple numbers and seeing what the outputs are and then connecting the dots.
Okay.
Now, you do have to be a little bit careful because you can't just connect the dots like straight. So you can't just draw a straight line. You need to know the general shape of the
Okay.
graph. And what we know about quadratics is that they kind of look like a U. Or they can look like this, depending on if it's negative or positive.
Okay.
and different kinds of functions will have different looks. So, um, if we have, uh, if instead our highest exponential is x to the 3, it'll look something like this. X to the 4 will again, x to the 4 will look very much like x squared, but it like kind of bottoms out sooner. So like x squared is kind of more like that. So like x to the fourth like hits the bottom kind of more, if that makes sense.
Okay.
So that's the general idea with like polynomials. Um, when you add like an x term and a one, uh, it's kind of hard to see those changes just like kind of by looking at the equation. But really, if you
Yeah.
just graph a couple of numbers, you'll get the picture.
Okay. Yeah, that makes sense.
Yeah. And then, so that'll be that for now. There are much more different kinds of functions. Square roots, uh, well, natural logs and logs, but you haven't learned about those yet. I don't think you have,
Yeah,
at
the
least.
functions are confusing and they get really long too. Some of them.
Mm-hmm.
And that's confusing, but
Yeah. You ain't seen nothing yet. Do you
yeah,
know?
it's crazy the stuff they give us like to teach on our own. I'm like, I don't even understand. I don't know.
Yeah. Do you know what kind of math you're gonna eventually stop at?
No.
Okay.
I'm like doing college counseling and they're trying to I'm like my counselor wants me to do like pre-calc or something next year. I'm like, I don't know. I don't
Yeah.
because I'm thinking about going back to school and I don't know how I'm gonna do with that, but
Yeah.
I'd like to
Pre-calc.
stop now with
Yeah.
math.
Yeah. 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 Pre-calc isn't too bad. I mean, at this point with where I am, everything from like pre-algebra to pre-calc is just algebra to me.
Yeah.
um, it's definitely different. Um, but pre-calculus has a lot to do with trigonometry, which you won't know yet.
Okay.
Um, how would I explain trigonometry? Um, so trigonometry. So let's say you have a right triangle. So a right triangle is a triangle with a 90-degree angle. Um, actually, you may have heard of this. If we have side lengths A, B, and C, what uh, what very famous formula uses these numbers?
I do know it actually.
Mm-hmm.
Um
Some of the numbers are squared.
it's I remember we learned them. It was like there was different ones, but I forget what's it called.
Pythagorean's theorem,
Yeah, yeah, yeah. Okay, I do know that.
or the Pythagorean theorem, and
Yeah.
that's a squared plus b squared
B squared
equals c
equals C
squared.
squared or something, yeah.
Yep.
Okay.
So what trig tells us, or well, trigonometry, called trig for short, is if we have an angle here, so say this is like 30 degrees or something.
Yeah.
Um, if we know, so trigonometry tells us if we have an angle, there is a specific function that will tell us relations about the side lengths of these. So, for example, the relation between B and A, so um, B divided by A, this number is equal to a specific function called tangent of
Oh my
that
gosh,
specific
yeah.
angle.
These are we did these last year in geometry.
Yeah, SOHCAHTOA.
Yeah, they're the worst.
Yeah. So pre-calc does a lot of this stuff because Calc 1 sine, cosine, tangent end up being decently important. But otherwise, it's just more algebra to me.
Yeah, I don't know if I want to do that.
Okay. Okay, so that's graphing. All right, so one of the things we'll maybe do a little bit of work on today is graphing.
Okay.
Um, how comfortable do you feel for like solving for like a variable?
I can do that, I think. Pretty good.
What if I
Because
give,
that's like,
yeah, go ahead.
no, sorry, you go.
Okay. What if I give you like um something like could you solve for z? Because normally how you're used to seeing solving for a variable is you only have one variable
Yeah,
or
that's what
two
I was.
variables really.
Yeah, no, I don't know if I could do that. That's the ones I don't like when it's all letters. I
What do you got
don't like
against letters?
because then there's like nothing. It's so hard to solve for. I can't understand it.
Yeah. So it's
At least
really
when there's
funny.
numbers, it's like
Yeah,
you can do
you
more.
can't use a calculator or whatever, right?
Yeah.
Yeah. So what's actually really interesting, so I come from like a physics background. That was what I mainly studied in college. And you actually don't put numbers into your equations until you're done, until you've reached your last step in physics. So physics is all letters. It's all you do. So like one of our equations is, well, there are lots of equations in physics. Um, oh, what's one for example that would be good? I'll say um, kinetic energy, 1/2 mv squared. So energy, kinetic energy is like movement, and m is mass and v is velocity. So this has something to do with like how big something is and how fast it's moving. You don't have to know the specifics of this, but oftentimes we'll be asked questions. Given how much energy we have, what is the speed that it's moving at? So what
Okay.
that means is we have to rearrange the equation for v. So how that would look is we can multiply both sides by 2 to cancel out the 1/2. So I'm just going to write e. 2 times e equals m v squared. We can divide over the m just like it's a number. M's will cancel. 2 times e over m. We have v squared. And then we can square root both sides so that the square and the square root will cancel. And we're left with v is equal to the square root of 2 times the energy over mass. But now, before we had the equation was set up so that we would figure out what energy is. Now the equation is we have it set up so that we can figure out what speed is.
Yeah.
So this is all algebraic manipulation. What I want so what a lot of my students have trouble with and what makes things really hard for like other classes is that their algebra isn't very strong. And it makes other things
Um,
really really difficult. So we may do a little bit of that work as well. Um, but I just want to show you the idea for a question like this. So
yeah,
we're trying to solve for z. So in order to solve for z, we have to know when we've actually solved for it. So what criteria do we need in order to know that we've solved for z? If you understand what I'm asking.
we need to like we have to have Z on its own.
Mm-hmm. Yep. So that's one part. So we need z on its own. Are there any other things?
Do you like is it okay to have like the X's and Y's, or do you want those to be gone?
Nope. We can have x's and y's as long as
And probably just
yeah.
have Z on the other side, on the equal side, maybe.
Yep. So that's a part of z is on its own.
Oh, okay.
Yep.
Um,
All good stuff. Keep going.
have them like, are they supposed to be lined up the right way?
What do you mean lined up?
Like not like how you were doing it before with the polynomials?
On this slide?
Yeah, like when you put it in the right order.
Oh, like this?
Yeah.
Um, no, that's not super important. So having it in a particular order matters if the formula we're using needed to be in a specific order. So
Okay.
like one of our properties of math says that we can actually, it doesn't matter how we add two numbers together. 4 plus 5 is equal to 5 plus 4.
Yeah.
This makes
Okay.
sense. So we can have these in any order we want.
Okay, then I don't know.
Yeah,
I
that's
think I
okay.
know.
Yeah. So what if I add another z here? Now, how does that change the problem? We're still trying to solve for z.
Um Wait, and that's a Z at the end too.
Yep, so we have a z here and a z here.
Um then you probably wait. You want to combine them?
Yeah,
Oh,
yeah,
combine the like terms or something?
yeah, very good. So
Okay.
not only do we want z on its own, but we only want one z.
Okay.
And here's why we want one z. So right here, it's actually very easy to solve for this particular z. All we have to do is divide by 5.
Yeah.
So we divide by 5 here, this
And
cancels,
then
and we have z on its own. Look at that, we solved the problem.
yeah.
But here's the issue. Z depends on itself. So
Okay.
think of this in like a real world example. Let's say someone's running around a track, and we have a function that tells us how far they run in a specific amount of time. And let's say how fast they run. We usually write that as v for velocity. How fast they run depends on how far they've traveled, how much time has passed, and how fast they're traveling. So we can't figure out how fast they're going if it depends on how fast they're going.
Yeah.
So
That makes sense.
yeah, we need to have whatever variable we're solving for on its own, and it has to be unique, which means there can't be any other of its kind.
Okay.
Which is why quadratics are really hard to solve, because we can't get x on its own.
Yeah.
Okay.
So then you just can't solve, like, how do you do that then if there's two of them?
Yep.
Two
It's a
X's.
great question. So before we move on to that, is there anything else I want to say here? No. So as long as z is on its own and we only have one z, that's fine. The other side of the equation can look like however.
Okay.
So we're going to use our old friend, the distributive method, or just distributive property. So I'm going to
Okay.
bring this over. So I'm going to subtract xz from both sides. So we're going to have x squared plus y is equal to 5z minus xz. So do you know what the distributive property is?
Yeah, like you can if you just like if you put it on the one side, you have to do it to the other side. You can't just do it to one side.
Um,
I know what it is. Like I know how to do it and stuff. I don't know
yeah, I
how to
think
explain.
what you're talking about, I forget what that operation is called. It's probably like a fundamental theorem of algebra, where like if you add 5 to this side, oh god, if you add 5 to this side, you have to add 5 to this side.
Or like if yeah, if you, or no, like if you take it, like if you take the positive um xz and then like you were wanting it to put it on the other side, then you have to subtract it to get rid
Yep.
of it on that side.
Yep. So, yep, that's true. It's a little separate from the distributive method or distributive property. So the distributive property says if we have uh, these numbers like this, so b plus c is in parentheses.
Oh, you can distribute it to both
Yeah,
number, like 9b plus 9c, it would be,
yeah.
right? Like when you distribute it.
Oh yeah, sorry. This is a poorly drawn A.
Oh, no, that's fine.
Yeah, but the idea is we can take this number, multiply them through. And
Okay.
if we go from here to here, it has a special name. It's called expanding. Your school may have used a different name, but this is how I know it. But these two forms are equal to each other. So that what that means is we can also go backwards from this form to the form with parentheses. And this is called factoring. It's
Oh,
also sometimes called condensing.
okay.
But what I want you to see here is that we can line up like this, and we can see that, oh, it's out of order, but we can see that the z shows up in both. So z can be like our a term, and then 5 can be our c and x, or 5 can be our b and x can be our c. Because a needs to be the same, so we need to choose z to be our a.
Okay.
But what this means is that because these two forms are exactly identical, we can rewrite it. So we can write it as z 5 minus x. And now
Okay.
what we've done is we've gone from having two z's to only one z.
Oh, that's good.
It's very good. Because otherwise we couldn't solve it.
Yeah.
So this idea of factoring using the distributive method in this way is very fundamental to algebra. It shows up everywhere. So we do have one more operation to do. We want to get z on its own. So we've got the first part, or we got the second part. We have one z. Now we need to get z on its own. How do we do that?
Now, do you have to like this? Like, do you need to move the 5 minus x back to the other side?
Yeah, you need to move the 5 minus x over to the other side. How do we do that?
Um, can you like add the x to both sides?
No.
Or no, that's not how it works.
Right. So because these are in parentheses,
Oh, they have to go together, maybe.
yeah, so they kind of have to go together. But so here's why. So if we add x to both sides, like this actually doesn't cancel, because if you remember, this term here is really minus xz.
Oh yeah. Okay.
So it's not just x. There's more to it. But because this is division, what we can do is we can divide this whole thing. So if we divide by 5 minus x, divide by 5 minus x, what we find is that these will cancel.
Okay.
Do you know why we're able to do that?
Um, because like when you divide by them, they cancel it. I don't know.
Yeah, it's because anytime you divide a number by itself, you get 1.
Oh, okay, yeah.
Yep, and this is true for anything. You can put the nastiest polynomial, um, If you divide it by itself, you get 1.
Okay, that makes sense.
So really what we're saying here is it's z times 1, but we don't really need to worry about the 1. And this is our answer. We have 1z, z's on its own, and everything else is on the other side of the equation.
That was actually pretty, like, that makes sense.
Yeah.
If I would have seen that, like, before, I would have just, like, not wanted to do it, but it makes sense now.
Yeah. Yeah. Okay. So that might be one thing we work on is just making sure your algebra is good.
Yeah.
Um.
Also, I am doing, like, I have to do, like, the SAT, like, prep soon, so,
Mhm.
like, maybe math for that too.
Sure. Yeah. SAT math is. I'm pretty sure it's just
Like,
algebra
everything.
and geometry.
Oh, okay.
SAT.
I think I have,
Oh, okay.
like, a tutor session with you guys, like, for the SAT thing. Like, I
Okay.
don't know if you guys do that. But
We probably do SAT math.
or I think it's just like, the whole SAT
Oh, the
prep.
whole ACT? Okay.
Yeah.
Okay. Yeah.
But I think I'll understand it mostly besides the math.
Yeah.
Like, I get everything else pretty well.
Okay. Yeah, yeah. So the SAT for math goes over algebra, geometry, uh, trigonometry, which is what we talked about a little bit with pre-calc.
Okay.
Um, it says advanced math. I'm not sure exactly what that means, but I'm pretty sure that's
Yeah.
just like you can work with numbers, like raw numbers, in a good way. And then some problem solving, so that's probably word problems,
Okay.
and data analysis. So that's all statistics.
Okay.
So
That's a lot.
it is, but it is really it's algebra, um, working with numbers, statistics, and then geometry and trig.
Okay.
And most of those, like the algebra and the doing numbers, kind of work together. Well, so algebra and geometry are very similar. Um,
Okay.
it's basically you're applying. So geometry is basically you're just applying algebra concepts in um, spatial ideas. So like area, surface area, perimeter.
Yeah.
Those are all spatial ideas, but it's all algebra. It's just the area of a circle is pi r squared. Uh, it's just like if you said it was pi x squared, it's the same idea.
Yeah.
Yeah.
My counselor said I could do statistics next year instead of pre-calc, which I don't really know. Like, statistics, is that like reading the graphs or no?
There's a lot of graphs in statistics. Statistics
I like
is
graphs. I get reading, like, I like on the test when they put like the bar graphs and stuff and you have to read them.
yeah, that's statistics. Um,
Okay, maybe I'll do that because I do kind of like, I'm good at those ones.
um, yeah, statistics has it's all data analysis and
Yeah.
stuff. Um, so you may have to do a little bit of like probability. Believe I forget if that's involved in that. Um, well, pre-calc does a little bit of probability as well. But yeah, that's up to you.
Yeah, I actually kind of like doing the probability. Like, if I was gonna have to pick, I don't mind doing that.
Okay.
It's kind of fun.
All right, so that'll be one thing we'll talk about. So we'll talk about graphing functions, just kind of algebraic manipulation. What about factoring, like quadratic factoring?
Yeah, we should probably do that too. I don't really know.
Okay, we'll we'll start off with so there's two big ideas with factoring. Um, So the first idea is called uh, greatest common factoring, GCF. And the second big idea is factoring polynomials.
Okay.
Usually quadratics. Usually quadratics, rarely third order quadnomials. So what's a third order quadnomial? Do you remember our naming system from before?
Oh yeah. So wait, is that like the wait? What's third order though? Is that just three? Like with three of them in it?
Mm-hmm. So
Oh, so a
the
trinomial?
okay, so the third order refers to the highest exponent.
Oh, okay.
The polynomial has to do with how many terms there are. So what's the highest exponent in the third order?
To like the third power?
Yep. So our
Oh,
highest
okay.
exponent is x to the 3. Now if it's a quadnomial, how many terms are there? Do you know what?
Four.
Yep. So there's x cubed, x squared, x, and 1. So this is a third order quadnomial. So
Okay.
but most of the time we're factoring something like this. Most of the time we're doing a quadratic.
Okay.
And there are many ways to factor a polynomial. Uh, there is, I'm going to say, basic quadratic factoring. There's the AC method. There is complete the square. There's the quadratic formula.
And these are methods for like how to figure it out,
Yep,
how to solve it. Okay.
yep. These are all methods for how to solve a
Are
quadratic.
any of them easier than the other ones?
Um,
Are they all just like as hard?
so they all solve slightly different things.
Okay.
So like the AC method is a slightly harder version of the basic quadratic factoring. So like the basic quadratic factoring only works if the term in front of the x squared is 1.
Okay.
The AC method is if we have a term other than 1 here. Complete the square works for both, and the quadratic formula works for both.
Okay.
But we'll talk about that. But the thing why I'm saying all this is there's only one way to do greatest common factoring, and it doesn't really have a name. It's just called greatest common factoring. You do greatest common factoring when you do greatest common factoring, believe it or not. Um,
Is that like when you have to do the factor trees?
maybe it's
Like like where you do like you start with the one and then they like spread out with all the numbers.
you start with the 1.
No, like you start with the number you're trying to find the factors of, and then
Oh, I think I know what you're talking about.
those are the
Yes,
worst.
we do have to. Yeah, those are the worst.
No, I can do them, but
So like if we had
just when you have like a really big
if we had
one.
18, it would be like 9 times 2, and then 3 and
Yeah.
3. So it would
Mhm.
be 2 times 3 times 3.
That's not too bad, but like some of the numbers get really big,
Yeah.
and then you have to do them really long.
Yep. So so this is I think you would call this a prime factorization. Do you know why?
Okay. Because it's a normal number. It's not like some crazy number.
It's prime factorization because you end up with just prime numbers.
Yeah,
So like
that's
you can't factor 2 or 3 any further.
yeah.
Yeah. So the idea with greatest common factoring, let me
Do you have to factor like numbers with decimals and stuff?
you can. Generally no. Generally you're just doing whole number factorization.
Okay.
So for example, if we look at this problem, we have 3 terms, and it's not just numbers, it's also variables. What we what the so the greatest common factor is, so if we break up 21 into its components, so 21 is 7 times 3. We can't break those any further.
Yeah.
And then we can break the x cubed into x times x times x. Good so far?
Yeah.
Okay, so that's one part. We can break the 9x squared into 3 times x, and we can break the 15 into 5 times 3 times x. So the greatest common factor is whatever like numbers are shared between all numbers that we're working with.
So the 3 probably.
Yep, the 3 is 1, but also there's an x that's shared.
Yeah.
So our greatest common factor here would be 3x.
Oh, that was easy.
Yeah, and so um, uh, for algebra, if we're adding these numbers together, so 21x cubed plus 9x squared plus 15x, we can do an analysis like this. And if we do a greatest common factoring when they're added together, we write the greatest common factor on the outside of parentheses, and we put whatever is remaining inside. So, for example, we would put 7 times x plus 3
Oh,
times x plus 5. So
okay.
this is, if we simplify this, this is 7x squared plus 3x plus 5. And this makes sense because if we multiply the 3x back through, like we're distributing, we get 21x cubed plus 9x squared plus 15x, which is what we started with.
Yeah, that makes sense.
Yeah. So
I'm sorry about the dogs if they're being loud. I don't know
that's
what they're
okay.
doing.
But this is the idea of greatest common factoring. And what's very cool about greatest common factoring is we can do this for any number of terms, and any number of variables.
Okay.
And sometimes this ends up being very helpful for us when we're solving algebra problems.
Yeah, that actually made sense.
Yeah. So
Yeah.
let me grab another one. We have an hour and a half, right?
Yeah, I think so.
All right. So this greatest common factoring problem, it's got two variables, x and y, as well as just normal numbers.
Okay.
So I want you to go ahead and try and find the greatest common factor.
Okay.
And feel free to switch between the slides if you want to
Okay.
look at what we previously did.
Wait, can I do it on the screen?
You should be able to, yeah.
Okay.
Are you on like a mouse and keyboard?
Oh yeah, I can do it. Yeah.
Okay. I would recommend, if you're on mouse and keyboard, to use the text tool, so you can write it like 15x3y.
Stop. Okay.
It'll be it'll be much easier than trying to draw it all out on a mouse.
Okay, yeah, that makes
Yeah,
sense.
I've got a drawing tablet that I use, so I have a pen.
Oh, okay. Yeah, that's probably much easier. So would it be -3, like for the next one? Or do I just
Um,
not do the minus for now?
so let me see. I don't want to explain this. So there's kind of two ways you can think about it. So you can
Okay.
either think about this as you're adding -3 x squared y squared, in which case the -3 is part of the 3. Um, and that'll work. Or you can think of it as subtracting is like on the outside. Both
Okay.
both work. Um, when we actually come to factoring negative numbers, we'll talk about that.
Okay, then I'll just do it like normal
Okay.
without the -3 for now. Do I have to do like 1 times 3 for factoring the 3, or can it just be 3?
Nope, it can just be 3.
Okay.
What's common?
They all have the 3's and the x's and the y's.
Mm-hmm. So they all have a 3. They all have an x. There we go. And they also have a y that's shared. Okay. So with that in mind, what are we gonna write for our factored expression?
Wait, where was the one from before? Can I look at the one from before?
Yep. Do you have the ability to change slides? It's usually at the top of the
Yeah.
screen.
Okay. And then do I do like the rest of it in the parentheses?
Correct. Yep. And this is actually something we haven't talked yet about. So,
Oh, sorry, I just deleted it. Oops.
you can hit redo, I believe.
Okay.
Okay, yeah, you can re-enter it too. Yep.
And then
So whatever.
do the rest of them?
What's up?
Like, do I do the rest of like the x's and the y's and the 2?
Yeah. So what's gonna go? So like on the last problem, the symbol that we had before just comes straight down. So if this were a minus, then it would be a minus down
Oh,
here.
okay.
Yep. So it's whatever symbol follows.
Okay. That makes sense. Okay,
Yep.
is that it?
Yep. Very good. Um,
Thank you.
I also will add a space between the terms for when like addition or subtraction,
Okay.
just kind of help break it up a
Yeah.
bit. But yeah, this is absolutely right. Okay, so this is great. Let's see, what do I? So I actually think you're pretty decent at math.
Really?
Yeah, I think,
Thank you.
yeah, I think, yeah, I think all I need to do is just explain it, and
Yeah.
you're good. Because I'm gonna be honest, I've had students where I have to like where this is really hard for them.
Really?
Yeah,
No, because when you explain it, it makes a lot more sense. I feel like that's the problem. Like with the online, I have no one explaining it to me, so then I just don't know.
yeah,
But like when you explain it, I get it more,
yeah.
I guess.
Okay, let me grab. There's one more I want you to do, and I think you'll be able to do this.
Okay.
I want you to. All right, I'll make one up. I don't like those ones. We'll do. Okay. So this, I want you to factor it, and I think you'll be able to do this without breaking it up into its components. All right, go ahead and give it a shot.
Wait, what do you mean without breaking it up? Like what shouldn't I do?
Um, so you don't. I think you'll be able to do this without breaking it up like that.
Okay. Okay. I'll try. Wait, so what do you do if the like cuz the 3 doesn't break up in anything, so they don't have like the common.
Yeah. So if there's no common factor,
So I don't have to do a common one.
yeah, for that specific, number. So what that means is there's no common factor between 4, 3, and 6. So you just leave them. You find other common factors to go for.
So you can do it like still with just 4 and 6.
Nope. So you have to
They
do it
can't.
for, it has to be for everything.
Okay. Okay.
And we'll talk a little bit about that once we get to the end of the problem.
Can it be the z? Like the z have like the z squared?
Mm-hmm.
That can be a factor.
Yep. Z squared can be a
Oh,
factor. So
okay.
we'll store that in our bank. Z squared can be a factor.
Yeah, I'll do. Can I just do that one as it?
It's
As a
not the
factor?
greatest factor, though. There's
Okay.
more you can do. You always want to pull out as much as you can. What about for the x's and y's?
Oh yeah, they all have an x.
Mm-hmm.
But the second term doesn't have a y. So you
Right.
can't do that.
Right. So we can't do the y, but we can do the x. Which we put down for the x?
Just x?
Yep,
Or do
just
you have to
x.
do x? Okay. Okay, yeah.
Yep, because there's one x. So there's only with greatest common factoring, it's limited by the smallest number. So the smallest
Okay.
number is x to the 1.
Okay.
Yep. So is that it for the greatest common factoring? Or I guess the greatest common factor.
Yeah, I think so.
Yeah, I also agree.
And then now you can do the parenthesis part.
Mm-hmm. Yep.
Okay.
So what'll come down for the first term?
4, 4, and then is there still an x? Because that one's like x squared.
Yep,
Okay.
there is still an x.
4x times y,
Mm-hmm.
and then you do the next one, so plus
Yep.
3, just plus 3.
Yep.
Okay. And then plus 6y, and then, wait, no, 6. Can you do 6y, or does it have to be 6 times y?
They mean the same thing.
Okay, so 6y times z.
Yep. Very good. That's correct.
Okay. That, like, if I would have seen that before, I would have not known what to do.
Yep.
So that makes sense.
Yep. So what you're asking about the 4 and the 6, you are right. So that those do share a common factor. Not the 3, though. So
Yeah.
if we wanted to factor that, how we could write it is inside the parentheses, we could take 4 and 6 have common factors now of, well, actually, let me ask you, what common factors do 4xy and 6yz have?
They have a 2, like, because 2 times 2 for 4, and then 2 times 3 for 6, and then they both have a y.
Yep, exactly. So what's our greatest common factor?
2y?
Yep,
Maybe?
2y.
Okay.
And then, so what's going to be left is 2x plus 3z plus 3. So the 3 we don't touch, but the 4xy and the 6yz you can factor inside.
Okay.
So
Yeah, that makes sense.
yeah, and that's as far as you can go, really. It's not
And then that's
common.
just the answer?
Yeah.
Like, that's just all? Okay.
Yeah, so it's not common that you'll factor this deep. Usually you stop here.
Yeah.
But sometimes you can do that and it'll be helpful too. Yeah, you can factor anywhere. Inside of parentheses, inside of a denominator or numerator, inside of like another function. So like if you have f of 2x plus 2, this is a function. It's inside of the function. This is equal to f of... You can factor anywhere.
Yeah. Okay.
We normally don't do math operations inside of a function, but in theory
Yeah,
we
but you
can.
yeah.
Um, so let's grade as common factoring. And um, really all this is the distributive method. Because you
Yeah, that
remember,
actually made sense.
yeah, our conversation was a times b plus c is equal to a times b plus a times c. Why can't, for this problem, we say, well, actually, we should have more terms. We should have a plus b plus c plus d, because we have 3 terms here.
Okay.
So normally we think of a, b, c, and d as numbers, but what's stopping us from saying a is xz squared?
Like because there's multiple terms in it and there's no like actual number. It's just like the variables, you don't know what they are yet. Or is
Well,
that wrong? Am
sorry,
I
I wasn't
wrong?
trying to like say like ask you like why can't we do it. I was just kind of being
Oh,
like,
okay.
why not do it? Why not, right?
Oh,
Yeah,
okay,
sorry
yeah.
about that.
No, that's okay.
No, but if you think about it, this here mirrors this, because this is kind of like our B,
Yeah.
like the whole thing. This is kind of like our C. This is kind of like our D. This whole thing. This is our A. So we can do this for anything.
Oh, yeah. Okay, yeah, now I get what you were saying. That makes sense.
Yeah, we could do this for anything, any amount of numbers. Even like we can even pull apart parentheses. So like if we have x minus 5 plus x minus 5, we can pull out x minus 5, and then we have 2 plus 3. So we can literally do this for anything.
Yeah. That makes sense.
Yeah.
Instead of like
Oh, I lost you a bit. No, come back. Man.